welcome to our studio, where we are going to give you a little demonstration of how water is distributed all around the globe. And what I have here is a series of beakers and containers so that I can give you that demonstration, and a globe so that you have a better representation of what we're talking about. First of all, I have filled up a large graduated cylinder with 1,000 milliliters of water. That 1,000 milliliters of water represents all the water that is held on the earth, in the clouds, in the rivers, in the lakes, in the oceans, and everywhere else. And to make it a little bit more appealing and clear, I have some food colorant, and I'm going to put a little bit of food colorant in here so that the water looks blue. So here we have one little drop, two little drops, three little drops. I think that will make it blue enough. And I'm going to use these to mix it all up so that it's all really nice and blue. So here we have the whole entire world water in one beaker, or what represents the whole entire world in one beaker. So the first thing I'm going to do is I'm going to pour on the second beaker the water that is held up on the oceans, especially on the Pacific Ocean, which is the largest ocean on the earth. And that amounts to 97% of it. So I'm going to go and bring this up to 970 milliliters, which is almost most of the water. There we go. Now it's getting mixed really nice. It's all nice and blue. More. 900, 950, 960, 970. So as you can see, from all the water that I had here initially, most of it has gone into the ocean, 97%. Now I'm going to go and take some of the water from here that we have left and put it on a smaller beaker. I'm going to put 24 milliliters of it, which represents what is on the North Pole, on the South Pole, and all the glaciers on the earth, including Alaska and including the high mountains like the Everest and Mount McKinley and whatever else we have that is high enough to hold glaciers in them. That's only 24 milliliters of it. So 24 milliliters, that's going to be more difficult. And I made 25, that's not what I want 24. So here is 24 milliliters. These 24 milliliters are ice. So what I'm going to do is I'm going to make a real magic trick, and I'm going to turn it into ice. And here we have the 24 milliliters in ice that is held on the North and the South Pole and everywhere else. Then from what I have left in here, I'm going to take out 6 milliliters of it. That is going to represent all the fresh water that is on the lakes, on the ponds, on rivers, streams, and anywhere else that there is any fresh water. And these 6 milliliters is going to be got 5. Okay, this 6 milliliters is all the water that we have maybe available in lakes, ponds, and places like that. I'm going to put it on a small beaker in here. And then, how much of this is for us available to drink? Well, only one little drop. That little drop is what we have available for us to drink. So as you can see, most of the water is held in the oceans. Some of it is on the ice, polar, North Pole, South Pole, the mountains. as a form of ice, and then a very little tiny amount is found on the lakes and the rivers and the streams and so forth, and from that only one tiny little drop is available for us to drink. If you're lucky to live in New England, you may have noticed that there is plenty of fresh water. The water is found in lakes, rivers, marshes, and it is also raining quite often. But in other places on the earth, that is not the case. Water, unfortunately, is not evenly distributed all around the globe. And in many places such as Africa, Australia, India, water is a hard commodity to come by. Through the years here in New England, we have developed many ponds and reservoirs in addition to many of our natural lakes. Water is all around us, but we need to keep it clean and protected. In the last 100 years, 50% of all our wetlands have been filled. Our streams are not available for drinking without additional purification, and our lakes and reservoirs have encountered their problems too. Think that anything we put on the ground ends up on the water, sooner or later. Pesticides, herbicides, and fertilizers added to our lawns every year are also added to our rivers. Help us clean our environment by educating other people and doing the right thing.